spend a little bit of time just now talking about a rather peculiar and perhaps funny problem that a farmer has relating to pulling a cow off the edge of a cliff that cannot get back into the field by itself. And so what we've got here is the cow dangling down and the tractor trying to pull the cow over the cliff with a pulley and a winch, I assume, or maybe just dragging it along. So the tractor has a mass of 1500 kilograms and the cow is 500. The tractor's engine applies a forward force of 6000 newtons and friction can be ignored between the tractor and the ground. So there are three questions here. First of all, what's the initial acceleration of the tractor as it lifts the cow? Draw a free body diagram and calculate the tension in the rope lifting the cow. So as we did before when we looked at the example of the carriages, if you've looked at that video on the website, there's also a similar situation here where we need to treat the system as a whole and think about what is the acceleration not just of the tractor but of the cow as well, because they will accelerate at the same rate. So we'll do that first of all, and then we'll try and figure out the tension in the rope itself. Now to do that, I'm just going to adjust the screen so we've got a little bit more space, and I've redrawn the picture showing the engine force and the masses of both vehicles. So to the first question, which is what is the initial acceleration of the tractor? So it says tractor, but really we're thinking about both the tractor and the cow. We're going to treat the system as a whole. And so if we treat the system as a whole, we need to think about what's the total mass of the system. And the total mass is the mass of both things, which is 2000 kilograms. And also, what is the unbalanced force on the system? Because if we want to determine acceleration, we really need to use Newton's second law, F equals ma. So the unbalanced force, well, we'll consider the two forces. We've already talked here about the engine force. That's one force pulling in that direction. You would look at the diagram, you might think, well, there are no other forces. There's no frictional force, the question said, but indeed there is. And that is the weight acting down here of the cow. And that weight is its mass times the gravitational field strength. So the weight of the cow is 500 times 9.8. And so if we just quickly do that calculation, we get a value of 4,900 newtons. So that's the other force, and so we can say that our unbalanced force is the difference between the engine force acting in one direction and the weight acting in the other direction. And so that is 6,000 minus 4,900. And so that means that our unbalanced force is 1,100 newtons. And now we can apply this formula that we've been trying to use all the time. So F equals ma. The unbalanced force is 1,100 as we've now determined, and that's the mass in the system multiplied by the acceleration. And so therefore our acceleration is 1,100 divided by 2,000, which is, according to my calculator anyway, 0.55 meters per second squared. So that's the first question done. We found the acceleration of the tractor, which is also, of course, the acceleration of the cow as well. So part B, draw a free body diagram showing the forces acting on the cow as it's being lifted. So let's take a different colored pen, let's say green, and we're going to draw the cow. There we go, that's my cow. As a good physicist, assume a cow is a sphere, and there are two forces acting on it, an upward force and a downward force. The downward force is the weight, and the upward force is the tension. And that's effectively all we have to do. I suppose if this were an exam question, you may want to write the words out in full, both weight and tension. So that's part B. And then part C, calculate the tension in the rope lifting the cow. So we know the weight, we know the tension, we don't know the tension. That's what we're trying to find out. So again, I'll go to a different color, maybe this time red. So let's think about the cow. The cow has a mass of 500 kilograms, And we also know that its acceleration is the same as the tractor at 0.55. So we can figure out the unbalanced force required to lift the cow. It's the mass times the acceleration, which is 500 times 0.55. So I'll just do that on the calculator now. And my calculator says 275 newtons. So that's the unbalanced force on the cow. And of course, that unbalanced force, F, is the difference between the upward force of tension and the downward force of weight. Now we know the unbalanced force is 275. We're trying to find the tension in the rope, and we know that the weight, we've already calculated that, is 4,900 newtons. And so therefore, we can easily solve this problem. The tension is the sum of these two values. And so our tension is equal to 4900 plus 275, which is equal to 5,175 newtons. So that's the tension in this rope right here, lifting up the cow. And we determined that by knowing the acceleration of the cow, because we know the acceleration of the whole system, and then finding the difference, or at least solving this formula. So that's how to do the problem. As you can tell, it's very similar to the train and carriage one. The only difference is we must consider in this case the weight, because that's the opposing force in this system.